Mars sample return is a mess. We got an update this week on NASA's ambitious program to return 30 carefully prepared sample tubes of Mars regolith and rock that are on the red planet. And as someone who wants very much for this mission to happen, frankly, I have some questions. I'm Swapna Krishna, and today on Ad Astra, we are going to talk about everything Mars sample return. That includes breaking down what it is, why it's important, why I do want it to happen, the challenges it's facing, and what NASA announced, as well as why I am not quite satisfied with what we heard from the agency this week. Let's start with why we even care about Mars samples. The Mars Perseverance rover landed in the Jezero crater on the Red Planet on February 18th, 2021. This landing spot was chosen very deliberately. Scientists think Jezero crater is the site of an ancient river delta, now dry, on Mars. NASA intentionally landed Perseverance in a place where it was likeliest ancient life could have thrived, in water. We think certain chemical elements, carbon, nitrogen, oxygen, phosphorus, and sulfur, as well as water, are necessary for any sort of life to develop. Perseverance is basically a robotic geologist that is specifically designed to look for indications ancient life may have once existed on the red planet. It even has found some promising samples. For more on that, check out my video on how Perseverance did not find life on Mars, but why scientists are excited about our particular rock. But it's important to note that Perseverance isn't designed to tell us whether life existed at one point or currently exists on Mars. That's a determination that can only be made by humans looking directly at Martian rock and regolith in a lab. That's why Mars Perseverance has been collecting and storing samples since it landed on the red planet. It's a very complicated and cool procedure. Here's how it works. The robot's percussive rotary drill takes a core sample and then docks it, where it's taken inside the rover to a place where the sample handling arm can grab it. The sample arm then pulls the full tube out of the drill bit, after which Percy images it with a camera inside the sample caching system. After that, a ramrod is shoved into the container to gauge the sample size, and then the tube is quickly sealed, after which another photo is taken. Then it's placed in the sealing station where the tube is more thoroughly hermetically sealed, and at that point it's returned to and stored in Perseverance. These samples are invaluable. Not only are they intended to be the first intentionally collected pieces of Mars that we can directly study here on Earth, we do have meteorites ejected from the Martian surface on Earth, but they're ancient and they've been subjected to the stress of re-entry and contaminated by Earth. But these samples could also directly contain fossilized evidence of microbial life. Every 10 years, different science disciplines conduct what's called a decadal survey, which basically outlines the highest scientific priorities for the next 10 years. For planetary science, the highest priority for 2 decades has been Mars sample return. It's a huge deal, and we've been working a very long time on it. Now, the mission architecture of Mars sample return is incredibly complicated. NASA has experience collecting samples from the moon with astronauts. China and Russia have both collected samples from the moon robotically. And then thanks to missions like OSIRIS-REx, NASA has experience landing on and collecting samples from asteroids. But Mars is a whole different story. First of all, Mars is much further than anything we've returned samples from before. While the asteroid Bennu, which was the target of OSIRIS-REx, probably originated as a main belt asteroid between Mars and Jupiter, it's now a near-Earth asteroid. It comes within 186,000 miles, that's 299,000 kilometers, of Earth every 6 years. Mars is, on average, 140 million miles, or 225 million kilometers, away from Earth. Launch windows only occur every 26 months if you're using the most energy-efficient home and transfer orbit, which would cut down on costs and use the minimum amount of propellant. And the journey to the red planet would take 9 months one way using the propulsion methods in use today. Not only that, but landing has to be pinpoint. To be able to collect Perseverance's samples, whatever craft lands on the Martian surface to collect these sample tubes has to land within 200 feet or 60 meters of its target site, because it has to be close enough for Perseverance to come back to it. Percy's top speed is 0.1 miles per hour. Pinpoint landings on other planets, when things like GPS don't exist, are hard to say the least. The previously approved plan, as a joint mission from NASA and the European Space Agency, or ESA, was as follows. There were 3 separate parts. The first is the robot Perseverance, which is on Mars collecting samples as we speak. The second part is the actual retrieval of the samples from the surface and returning them to Mars orbit. The third is the Earth Return Orbiter. With the new plan, the overall architecture is the same. Where NASA changed things is within that middle part, how we'd retrieve the samples from the surface. Originally, the plan was to launch a sample return lander in 2028, which would also travel with the Mars Ascent Vehicle, or MAV, and 2 sample recovery helicopters similar to Mars Ingenuity. The Mars Sample Return Lander would have 5 solar arrays, weigh almost 7,500 pounds or 3,375 kilograms, and be the average size of a 2-car garage. Not small, nor lightweight. Landing this thing was going to be a real challenge, hence why NASA was planning on building an entirely new spacecraft from scratch. The 2 Ingenuity-style helicopters were to help collect samples in case Perseverance struggled to come to the landing site. The Mars Ascent Vehicle is a separate 2-stage solid-fueled rocket currently being developed by Lockheed Martin. Once the samples are safely on board, it will take off and enter Martian orbit. At that point, the payload fairing would eject the sample container into orbit. The spent second stage of the rocket would remain in orbit and broadcast a signal to make it easier to find. Then we come to the third part of the mission. The sample return container would dock with the Earth Return Orbiter developed by the ESA. On board would be the NASA Capture and Containment System for safeguarding the Mars samples. The ERO would be able to home in on the broadcasted signal in order to locate the sample container. Once it's locked on, it would slowly and carefully overtake the sample container and then basically swallow it. Once a sample container is safely on board, the capture and containment system would be sealed, safeguarding the samples, after which an onboard robotic arm would place the entire thing into a capsule designed for Earth re-entry. The spacecraft would then head back to Earth and would release the Earth entry vehicle when it's 3 days away from our planet. The Earth entry vehicle would be designed to re-enter without parachutes and would touch down in the same location as the OSIRIS-REx samples, the Utah Test and Training Range. Well, back in 2024, NASA announced that with this mission architecture, the mission would cost $11 billion, and the samples would not get back before 2040, which is why NASA started looking at alternatives. I also want to add that there's some additional schedule pressure here because China is planning on a Mars sample return mission by 2030. In the grand scheme of things, I don't think it matters much who does it first, but beating China is a big priority of the Trump administration, so doing this quickly matters in that respect. NASA's announced changes to MSR aren't overly dramatic. The overall mission architecture, meaning the 3 separate parts, Perseverance, the sample lander and ascent vehicle, and the return to Earth, have to pretty much stay the same. There's no feasible way to combine any of this without incurring significant additional costs and complexity. Having to build entirely new spacecraft from scratch adds a lot of time and money, so NASA started looking for ways to reduce that. What they announced is basically some changes to the middle part of the mission, specifically the Mars Sample Return Lander and the Mars Ascent Vehicle. Perseverance is obviously already on Mars, and so no changes there. And the Earth Return Orbiter is being built by the ESA, and that's staying the same. There's 2 possible strategies. Both involve cutting down the size and mass of the Mars Ascent Vehicle, which would in turn mean that the Mars Sample Return Lander could be much smaller. They would also cut weight from the Mars Sample Return Lander by switching to nuclear batteries instead of the solar panel array. This cuts down on costs, as well as gives NASA more flexibility because they'd be able to operate during dust storm season. It would also have the added benefit of warming the solid rocket motors on the MAV. They're also doing away with the Ingenuity-style helicopters because NASA has confidence that Perseverance will be able to trek to the landing site to deliver samples. I want to note there are 10 additional samples stored around the Jezero crater that the helicopters were supposed to retrieve. These will remain on the red planet. Only the 30 stored on the rover will come back. So, with that in mind, let's outline the two options. First, using heritage and flight-proven technology to land it. Because of the significant weight reduction, the entire package could be delivered to the Martian surface by the sky crane, which NASA has successfully used to deliver both Mars Curiosity and Perseverance to the surface of the red planet. This would involve lowering the Mars Sample Return Lander and the Mars Ascent Vehicle with a cable attached to a rocket stage hovering above the ground. The sky crane would need to be about 20% bigger than the one used for Curiosity and Percy. The second option is partnering with a commercial company to build a lander and a landing mechanism that would work for NASA's purposes. There was also the question of whether we return the samples directly to Earth or return them to lunar orbit, which would, again, make the process of getting the samples off Mars and back to the Earth-Moon system less expensive and faster. But NASA still prefers returning them to Earth because we'd have to go get them from lunar orbit, though by this point, if Artemis stays as is and isn't significantly modified by incoming NASA Administrator Jared Isaacman, we'd have the Gateway space station in orbit of the Moon. The idea is that even then, it would incur additional cost, increase the complexity, and it would just take longer to get the samples back to Earth. Remember, the thing that prompted this redesign was a cost estimate of $11 billion being way too expensive, and the fact that the samples wouldn't be back on Earth until 2040 or later. This revised architecture has an estimated cost of less than $8 billion. The earliest launch possibilities, according to the Associate Administrator of NASA's Science Directorate, Nikki Fox, would be 2030 for the Earth Return Orbiter and 2031 for the Sample Return Lander. We don't have an estimated return date for the samples. All Dr. Fox said was that NASA is confident it would be before 2040. I have thoughts and I have questions, so let's get into them. Let's start with this. NASA has not made a decision between the two options. That will come in mid-2026 and will be the responsibility of the new administration. I'm going to stress again that I want Mars sample return to happen. I personally think it's important. But this entire thing feels a little bizarre. I'll get into each of these points, but in sum. First, they didn't have a decision to announce or anything concrete to say beyond we aren't canceling the program. 2, we're still not getting all the sample containers back, which was a big emphasis of the April 2024 press conference. 3, it's still going to be really expensive and it's money that NASA does not currently have. 4, I personally still think their schedule might be unrealistic. And 5, this honestly makes me question NASA's ability to even execute a program like this at this point. Let's start with punting the decision. I don't want to criticize NASA for holding a press conference, because I think frankness and information disclosure is a good thing, but there was nothing really to announce here. There's been no decisions made, and we all suspect that the agency is going to go through a drastic reorganization under the new administration, so what they announced may not even be relevant at the decision point in mid-2026. The timing of this conference very much felt politically motivated. NASA wanted to announce something, so their work on the program up to now is public record, and to make MSR harder to cancel, as well as emphasize the need to fund it. It's especially interesting considering they did make decisions on the Orion heat shield last month and did not leave that to the new administration. Feels a little bit like they're picking and choosing here when both Artemis and Mars sample return are supposed to be top priorities for the agency. And to be clear, they do need the extra time to refine options and do the engineering analysis. They are not ready to make a decision right now. But the fact that they're not ready to make a decision is indicative, I think, of a larger problem at NASA. Here's the thing. It's not like Mars sample return is new. NASA has been working on Mars sample return for decades, since the discoveries of the Viking landers in the 1970s. It has been a flagship mission for NASA since 1988, This is not new. This has been a top priority since the 1980s. So how are we now, in the year 2025, still hearing about how NASA is trying to simplify the complexity of the mission by changing out some components on the Mars sample lander and making the Mars ascent rocket less heavy? It just seems very basic to me. NASA has been working in less than ideal budget environments for literally decades, basically since the first budget cuts of the Apollo program before we even landed on the moon in 1969. Since then, they have not had enough money to do everything they want to do in the way they want to do it. This is not new. This is something NASA is very used to. And let's look at the timing as well. The MSR Independent Review Board was convened in May 2023, which, by the way, wasn't even the first independent review board for Mars sample return. There was another one in late 2020. The second review board delivered their report in September 2023. The program was basically scrapped to be redesigned in 2024. It's now January 2025. That's almost 2 years, and we still don't have a decision on Mars sample return. It's frankly hard to listen to a press conference like this and not think NASA has been in a limited budget environment for decades and has been trying to cut costs. Why wasn't this updated architecture something considered years ago? What's more, the MSR Independent Review Board made it clear that the then current version of MSR had both an unrealistic budget and unrealistic schedule expectations from the beginning. And I'm honestly not sure that even the current, newly announced budget and schedule expectations are realistic. Back in September 2024, the NASA Office of the Inspector General issued a report on the challenges and risks associated with keeping the International Space Station in orbit until 2030 or longer if necessary. It's a really interesting report, but one of the key takeaways for me was that the USD orbit vehicle, which NASA contracted with SpaceX to develop in 2024, very well may not be ready in time. The vehicle is supposed to launch in 2029, but the report points out, quote, other major NASA spaceflight programs that have, on average, taken about 8.5 years from contract award to first operational flight. Now, I'm not overly worried about USDV because it's based on Heritage Dragon hardware with just a modified trunk, but the point stands. 8.5 years is the average. For example, the first contract award for SpaceX's Crew Dragon was in 2014. The first operational mission was in late 2020. We're not going to even talk here about Boeing. For the Mars sample return lander, let's be generous and say it takes that same 6 years, which is not an unreasonable prediction. It needs to be designed for Mars, but it doesn't have to deal with the life support system to support humans. The decision point for which option NASA is going to pick is mid-2026. Then they have to award the contract. So let's say that doesn't happen until 2027. That means that if we're going with 6 years, the vehicle wouldn't be ready until 2033. There is a launch window for Mars in 2033, but if NASA isn't able to get the vehicle ready in time, then let's say the next launch window, 2035. And keep in mind, we're talking about 2 different vehicles integrated into one here, the lander and the ascent vehicle. So even if it's all close to being done, I don't think it's unreasonable they may not be able to integrate it all and get it ready for launch to make a 2033 window. So let's say they launch in 2035, arrive in 2036, then wait for the next optimal home and transfer window to come back, which would be middle of 2037, and then the samples don't get here until 2038. That's not much better than 2040 in my opinion. And let's look at the costs as well. We're talking $6 billion to $8 billion more. It's cost $20 billion to date. I'm not actually criticizing that cost here. It's a flagship mission for the agency. We always knew it was going to be expensive. Flagship missions should be expensive. They should be daring and cutting edge. But my point is that NASA didn't have $11 billion when they decided to redesign the mission last year. And they don't have $6 to $8 billion now. One of the first things that Administrator Nelson said during the press conference was that Congress needed to start funding MSR in this fiscal year, or it's not going to happen. And again, because I'm pretty sure they're not going to make a 2030 launch window, it's probably going to be even more money than they have stated. I should say that part of that is strategic. NASA does know it's probably going to be later than 2030, but they don't want to say that because it sounds bad. This new approach gets back the bulk of the sample return containers, 30, which is better definitely than not getting any of them back at all, but it doesn't get back all of them. And I already know that the comments are going to be full of people asking why I'm being so mean to NASA. Look, I love NASA. I have so much respect for the agency and the people who work there. I know a lot of people who work there and they do amazing work. I have so much respect for NASA, and that's why I'm disappointed here. My job isn't to be nice to NASA, it's to look at what they're doing and to be honest in my analysis. And so if I'm being honest, I just don't see this happening. I'd love to be surprised because, as I've said, I think MSR is important, but I don't see a way in NASA's current budget environment and with an incoming administration that's set on cutting back to make a mission like this work. I think a lot of us are starting to ask questions about NASA's capability to manage large missions like this, given what we've seen. I often talk about how difficult it is in this day and age to be a space reporter when it seems like every company is a space company. The beat is just so big, from the history of the universe to astrophysics to planetary science to space policy to politics to spaceship engineering to medical stuff, the health of the astronauts, to environmental concerns. During the eclipse, I had countless people asking me to analyze weather forecasts. I am a space reporter. I do not know anything about the weather. But we're expected to be able to cover all of this stuff and be able to do it competently. It is hard, and I feel like that's a little of what NASA is dealing with on a much larger and bigger scale. When the entire agency was focused on one goal, going to the moon, they were really at their peak and they were able to accomplish amazing things. And to be clear, they are still able to accomplish amazing things. Look at JWST, for example. But the fact remains that it seems like they're trying to do so much that they're struggling to make progress on their top priorities because there are too many top priorities. And I think we're seeing that in both Mars sample return and the Artemis program. We will see what happens. I really do hope they find a way to make MSR work. And that is just about all I have to say about Mars sample return. Thank you for watching. I am Swapna Krishna, and this is Ad Astra.